Okay, we're gonna look at number 5 again, since I made a little error in my addition from the video. So here it goes. So the first thing I did is I already have the augmented matrix, and I wanna think about, again, if I'm using Gaussian or Gauss-Jordan elimination, I want the diagonal of 1s with my zeros below, and if I'm doing Gauss-Jordan, then I'll put zeros up above. So we'll see how that goes. So the first thing, trying to get a 1, there is no 1 already in the first column, so I got to figure out another way to get a 1. And there's a few different ways. One of the things I noticed is that everything in the third row is a multiple of 3. So if I divide by 3, I won't create any fractions, and it would create a 1. So if I do that, if I take 1/3 of row 3 to make my new row 3, that means, again, row 1 and row 2 are unchanged. -2, 4, 1, 7, 4, -13, 10, 17. But row 3 becomes 1, -3, 2, 3. And then I'm going to interchange those two rows. So row 1 interchanged with row 3. That's going to get me row 2 keeping the same. But row 1 would now be that 1, -3, 2, 3, and the bottom would be -2, 4, 1, 7. So the next thing I want is to turn the 4 into a 0. So I'm going to use the 1 that I had created. I'm going to multiply row 1 by -4. Add that to row 2 to make my new row 2. So again, the only thing that changes is row 2. So row 1 is still 1, -3, 2, 3, and row 3 is still -2, 4, 1, 7. And the second row, well, let's do some little scratchy work. -4 times row 1 will be -4, +12, -8, -12. And row 2 is 4, -13, 10, and 17. So when I combine those together, that's 0, -1, 2, and 5. So that's my new row 2. So 0, -1, 2, and 5. So then the next thing that I want to do is get rid of, let me make this a little bit better first. This was -2. Okay, we want that guy now to become a 0. And so we're going to need a +2. So I'm going to take +2 times row 1, add that to row 3 to make my new row 3. Make all that come over here. So my matrix will still have the same row 1 and 2, since row 3 is the only thing that's changing. So row 1 is 1, -3, 2, 3. Row 2 is 0, -1, 2, 5. And so row 3, my little scratchy work, 2 times row 1 is going to be 2, -6, 4, 6. And my row 3 is -2, 4, 1, 7. So it becomes 0, -2, 5, and 13. That's my new row 3. 0, -2, 5, and 13. Okay, my next step is to make sure that, since I got the first column done, I want to make this -1 become a 1. Well, that just means I want to multiply row 2 by a -1. And that will make my new row 2. So the only thing, again, changing is row 2. So row 1, I'll write 1, -3, 2, 3. Row 3 is 0, -2, 5, 13. And my middle row will be 0, 1, -2, -5. Then I want the -2 to become a 0. That means I need a 2 times the one I just made. That's always the guy you use, is the 1. That's kind of the easiest. So 2 times row 2 plus row 3 to make my new row 3. And so the only thing changing here is going to be my row 3. So row 1 is 1, -3, 2, 3. Row 2 is 0, 1, -2, -5. And row 3 will become, well, let's do my little scratchy work again. 2 times row 2 is 0, 2, -4, -10. We're going to add that to 0, -2, 5, 13. That was my row 3. So we're going to get 0, 0, 1, and then a +3. So 0, 0, 1, +3. And so I'm going to stop here because I've done Gaussian elimination by getting the diagonal ones with zeros below. And I'm just going to do substitution now. I'm going to rewrite the equations. X minus 3y plus 2z equals 3. Y minus 2z equals negative 5. And then z equals 3. So we found our z. We just have to back substitute now. And so if I plug into that last equation, that's y minus 2 times 3 equals negative 5. Y minus 6 equals negative 5. If we add 6, we get y equals 1. And then we're going to take both of these now and plug into the top equation to find x. So x minus 3 times 1 plus 2 times 3 equals 3. That's x minus 3 plus 6 equals 3. X plus 3 equals 3 minus 3 minus 3, and we get x equals 0. So the solution to number 5 should have actually been 0, 1, 3.